Oh, got it. Okay. Hi, everyone. Welcome to the CRAN chat, which is topic today is kind of bringing sustainability into our design world and knowing kind of more about it to allow us to be sustainable and know kind of what we're doing to design with it and make things look beautiful as well. So Greg Howe and myself are both on the CRAN steering committee, and we thought this was a good place to bring together both HVAC and solar in an intimate setting where you guys can put your comments in chats and we can address comments and questions people have. Before we get started on all the introductions, which Greg is going to do with our two guests, I wanted to take a minute to thank the people that sponsor CRAN. So if you don't know, CRAN is the Custom Residential Architects Network, and we host several events a year, from the big symposium, which is in May, to social events, to these CRAN chats, which started during COVID, to be able to just have intimate kind of Zoom connections. So I'm going to go ahead. We have several sponsors that have really make these events possible. So I'm not going to list them all, but they are here on the slide. Just thanking the people. And if you know anyone in these businesses, you can thank them as well, because they really do help support all the work that goes behind these. We have our highest level supporters, which is the 1869 Circle Partners, which as kind of collectively support all the different events that CRAN puts on. And they are largely geared towards residential. So I'm going to stop sharing and turn this over to Greg, who will introduce our guests.
All right, thanks, Celeste. And thanks for AIA Chicago for organizing this, and Sean and Garrison for taking part. So starting with Sean, Sean Mansfield is the general manager of AA Service Company, heating, cooling, plumbing, sewer, and electric, which provides contractor home services for Chicago and the North Shore area of Chicago. Sean's been providing engineering consulting and best practices consulting in the HVAC and plumbing industry for the last 30 years, and has been focused on residential construction and green systems designs over that period of time as well. I think he's a name well familiar with the CRAN community and has generously taken part in previous programming as well. Shifting from Sean to Garrison Regal. Over the last 19 years, Garrison has overseen the design and installation of more than 1,100 residential and commercial photovoltaic systems. In the summer of 2020, Garrison founded Celestar Solar. As an anecdote to the quality, reliability, and integrity issues he was seeing in the high volume solar world at the time. The mission of his company is not to install the most solar, but to install systems with safety, quality, and care as guiding principles of design, which I think hopefully all of us as architects share as well. So Sean is going to get started, followed by Garrison, and then once both gentlemen have the opportunity to present, we'll have a Q&A session at the end. So Sean, would you like to
Great, Greg.
start things off?
Thank you. I appreciate it. Number one, I'd like to thank AIA for having me back. It's a privilege to be able to do this every few years and to be able to present to this great group a topic that is near and dear to my heart. So let me just get my screen shared here with everybody. Number one, I just want to start off by, again, introducing myself. So Sean Mansfield with AA Service Company, heating, cooling, plumbing, sewer, and electric. I graduated college as a mechanical engineer, and I've been practicing mechanical engineering since 1994 in the Chicagoland area. My first 13 years, I was in the manufacturer's rep side of the business, and I worked with a lot of the large consulting engineering firms in Chicago. But my passion's always been more to the residential side, and more collaborative designs, and unique designs. So the last 19 years I've been practicing in the residential world, designing, consulting high-end custom residences, focusing on sustainable design principles. And then we're also an installing contractor to do the same. My background and upbringing, I grew up in the Midwest, and I believe that my duty as an engineer is to make sure that we are spreading best practices in the world of sustainable designs. My design philosophy is pretty simple. I believe in maintaining a good base of design principle, understanding why we're applying something, and then making the best choice for the application. The marketplace was asking for these sustainable designs, so it's an area that I got interested in, and there was a void that needed to be filled, and we were happy to step in and help. I have a pretty unique perspective as a designer and an installer, so it allows me to kind of bring that unique approach to the projects I work on, which I believe is really critical for true sustainable design work. And then I'm always kind of looking to the future and trying to figure out what's coming next and how we can try to get out in front of those things to try and ensure that we have the best plan in place for us, so that when it becomes ready to be applied across a wider berth, that we're ready to help apply that. So when I think about sustainable HVAC impacts today, some of the items I really think about is the sustainable HVAC design principles, electrifying the HVAC systems at a residence, talking about utility rebate programs, and then talking about the government tax credit and rebate programs that are out there for us to be able to apply to some of those sustainable design principles. So when you talk about sustainable design principles, we want to work with the architects first and foremost to make sure that we can minimize the loads. We can always throw larger mechanical systems at things, but when it really comes down to talking truly about sustainable, we want to make sure that the parts that I have to mechanically address are as small as possible. And whether that means solar shading, direction that the house points, the quality of the windows, the quality of the insulation, whatever those things are, the envelope is a great starting place where we work together with architects to ensure that the sustainable design is as positive as possible. A lot of energy modeling is being done by all your offices these days. This is nothing new, but how that house points, the overhang of the house, the trees, etc. All those kind of go into the amount of solar gain the house takes on, which affects the load that the house has. Next is finding the right approach for the project. Pick the right system for the job. That is important because there's lots of choices out there today, but trying to understand which one the right one is very important. Picking the right system for the client. Not every client has the same wants to address the same load. So understanding what that is and how we can assist. Pick the right HVAC system to complement the carbon neutral goal for the project that's going on. And then next, apply all those appropriate additional tools for comfort. So we've always had an actual focus on comfort at AA Service. We want to make sure that we're focusing on comfort and simplicity in designs. Those tend to give you longer life expectancies, less overall cost. We want to size the equipment appropriately for the project. You're actually trying to shoot to undersize when it comes to HVAC systems. Bigger is not always better. Most people believe it is, but in the world of HVAC, especially talking sustainable, bigger is not better. And then we want to apply humidification, dehumidification, fresh air filtration to improve comfort as well. So, why are we looking to do a sustainable design is an important question that we always have to ask. Ultimately, the first question to ask is what is the goal? Why are we talking sustainable design on a particular project? Does the customer look to be carbon footprint neutral? Do they just want to reduce fossil fuel usage? Are they just interested in payback, savings, self-sustainability of their systems? Understanding those versus comfort and which one of those is most important to a customer can really help us to determine best what is the right sustainable design for a project. But we also don't want to forget to consider all these other items too, which is the upfront costs, the overall operating costs of those systems, service and maintenance costs that go into those systems, local expertise and feasibility to apply those sustainable designs in a particular area, the longevity of the equipment, maybe the size, the shape, the location of the equipment, and then the accessibility of that equipment once it's installed. And then finally, do we have, IAQ concerns that we need to try and either figure into the design or create side applications for to address them. There's a lot of different ways that you can apply sustainable designs today on the HVAC marketplace. A traditional way of doing it is a furnace and air conditioner. They certainly have some very high efficiency traditional systems that are out there today. They're kind of your good, better, best. They're going to be your good level starting point for someone looking to do a sustainable design. There are other ways to heat and cool in our area. Certainly radiant heating systems paired with high efficiency boilers are another great way to create a very sustainable design when it comes to no moving air in the house, that you're just using the radiant floors to heat. But at some point we still need air conditioning. So it tends to be a duplicitous approach where you also have to put air conditioning systems in that are separate from your heating. Very big way of doing sustainable designs that we've been involved with over the last 10 or 12 years have been air source heat pump systems, variable refrigerant delivery systems. These provide for the opportunity to use more electric power to do your heating and cooling than gas. Certainly geothermal is a key word that's out there that many people recognize. Geothermal systems use the earth itself to be a battery to allow us to store heat from the house for one season, to pull that heat back out from the earth in another season, to try and really minimize the amount of energy that we use. And, there's still brand new technology to come. There's always new developments going on in the industry when it comes to, the best ways to create new sustainable designs. So electrifying or hybrid, which one and why? These will be some things that we can talk through during the breakout, the future Q&A session, and just kind of talk through why we choose to do one versus the other. I've got some slides I can share when we get into Q&A in regards to some of these ideas, but there are two different ways that you can go. Many customers today talk about wanting to be able to fully electrify. They want to get completely off the gas out of their house. Those things are great, but there's a lot of things that go into the how when it comes to those applications. For someone who's looking to just do more than use natural gas, the hybrid systems that are out there today, which use air source heat pumps to do both heating and cooling, the same job the old air conditioner outside used to do, are opportunities for us to come up with a hybrid where, depending on the local utility costs for electric and gas, we figure out that sweet spot where we go from using the electric heat pump back to using the gas. Maybe that's 30 degrees, maybe it's 40 degrees, maybe it's 20 degrees. It's a microeconomics problem for any location where you apply it. You have to figure out the utility cost break where it makes the most sense. But most of the manufacturers today are coming up with software that can help you make that decision and figure out exactly when it's the best place to use one of these. Certainly going to a hybrid is going to be less expensive than going to an all-electric or going to geo. So in a good, better, best, it can give you a lot of the opportunities without a lot of the cost, but certainly doesn't get you to the lowest carbon footprint. Any heat pump approach, is a good option for looking to do sustainable design. Some of the questions that I typically get asked that we can go through later are, how can I go fossil free? How can I get rid of the gas in the house altogether? How do they look and sound? Special considerations for installations when we apply these systems. When do you switch over in an electric or hybrid system? When do I know to go from using gas to using electric or back and forth? Is it automatic? Can it just be set up in the thermostat? What things should I do before evaluating going to all electric? And then also along with all that's kind of understanding the different items that are out there to choose between. For your full electric approach, there are a number of pros and cons. Do I have enough electric panel to support? That's something that Garrison's going to speak to a little bit during his presentation. Will the air temperature feel different in the house if I go to an all-electric approach? The answer is definitely going to be a little bit, but is it enough to be an issue for most? Probably not. Do I do one large system or a bunch of little systems to replace my existing system? All these things are opportunities that are out there when it comes to trying to fully electrify a house. Do I go ducted or ductless? I know I'm talking to a lot of architects in this seminar today, so most of them are not appreciative of things being hung on walls that aren't art, but they are certainly options to be discussed with customers who truly want to look at the lowest cost and highest efficiency systems that can be applied, and those are units that don't have ducts connected to them. So how far do you go? Again, for the hybrid systems, high efficiency furnace, you can either use a high efficiency air conditioner to get you a little bit of bang for your buck. You can go to a standard heat pump, which gives you a little bit of cross application of electric versus gas. Or they have the new low ambient heat pumps that are out there today that run all the way down to minus 20 degrees outside, and can really help try to run more electric and less gas before you have to switch over. Ultimately, though, for most of these hybrid applications, at some point you run a little bit of gas. And so it's different than going to an all-electric, removal of fossil fuels from your home. When do I consider geothermal? Certainly geothermal is the highest upfront cost option, but it is the lowest carbon footprint energy saver out of all the applications. During the Q&A, I've got some slides I can show to that effect, but every time that you're doing these things, there is no one answer for any one design house, because the microeconomics of Chicago are going to be much different than a house on propane gas in southern Wisconsin. Everyone's electric costs are different, everyone's natural gas costs are different, or propane costs are different. Or even on the East Coast, they're dealing with oil being removed and going to electric systems out there. So it is a microeconomics equation anytime you talk about sustainability and what system is best for a particular area. For geothermal, do you have yard or acreage? Do I have a yard space or none? Do I want the most efficient system out there? And a lot of times that's why people look to the geo systems. So sustainability, other questions we get into: smart thermostats, energy tracking systems, smart panels, continuous efficiency improvements, improved renewable energy sources. Can you buy your power off peak and use that? That's again some of the stuff Garrison will talk to. Linking HVAC designs to house battery systems for that off-peak energy usage. All those things allow sustainable HVAC designs to be paired with other sustainable components within the house. One question that always comes up is there a great place for us to find out all of the things that we can look to get rebates and tax credits? This is a great website for that. Of course, always be careful when Googling Desire USA. So try to get the address correct. It can get you into weird places if you don't. But www.desireusa.org is a great site. You can click on the state you're doing your work in, and it'll list for you all kinds of different programs that apply for sustainable designs, where you can find grants or credits or other things that might help your end user to get some money back for going a particular way. Lastly, too, talking about the local utilities and understanding what they have. ComEd locally has rebates for heat pump systems and geo systems that are quite substantial, that can help to offset some of the costs associated with those. So that's kind of a basic overview of the items that I'm happy to talk about through our Q&A session. And hopefully I've addressed a number of the thoughts you already had in regards to questions. And I look forward to speaking a little bit more in the next few minutes when we break things out.
Thanks, Sean. That was great. So Garrison, interesting to hear how you add to the conversation.
Yeah, sure. I will jump right in here. Should I start sharing? Is that now a good time? All right. Let's see here. Sorry, getting this pulled up. All right, a little technical difficulty here.
Okay, take your time. I know you guys have worked together in the past, so it's, I'm glad we were able to have two people that have done work together for this.
Celeste, there's a great question in the question and answer while Garrison gets started, asking about they use Revit and what energy modeling software gets used. Generally, the energy modeling is done at the architect level, so I'm not actually doing that. Do you have a good suggestion on that?
Me?
Yes. Do you guys do energy modeling at your office, and do you have anyone that you've worked with on that?
We use Revit, but I feel like we do res check rather than energy modeling, but John, I know is on here, so he can maybe answer that better.
All right.
Okay, well, maybe
Oops, sorry.
while he's typing, maybe we use ResCheck. We also use a plugin to Revit for modeling as well, which is becoming easier progressively. It's a familiarity factor, I feel.
All right. Can everyone see my screen here? Do you see some solar panels? All right.
Yes.
Great. Okay,
Yes.
cool.
Perfect.
All right. All right. Well, yeah. Hey, everybody. Thanks so much for having me here. I happy to talk with architects. I've been in solar a long time, since 2005. I like to say since before solar was cool. And the industry has been pretty rocky over the last 20 years. And I gotta give credit to architects. Through some of the leaner times when subsidies weren't around, or there's uncertainty in the marketplace, architects were still incorporating solar designs into their projects. And I and previous colleagues of mine have a lot of relationships with architects in the Chicago area, maybe some of you that are involved on this call today, that really helped keep the solar going in Illinois. And when times were sort of uncertain, architects speccing solar into their projects from the get-go, it really kept things flowing. Now solar has changed a lot, and it's a booming industry in Illinois, but it hasn't always been the case. And but architects have really helped move the ball forward. So appreciate that. I have done, I think Greg said 1,100 systems was in my bio. It keeps going up, luckily. I think I'm a little over 1,200 systems now installed mostly in the Chicago area. My classical training is in the natural sciences. That's how I sort of got interested in solar. And while I was studying natural sciences, I was building houses. So I was working as a carpenter, basically taking instructions from architects. But then I wanted to get into something that was a little more sustainable. So I wanted to keep building, but I wanted to, idealistically save the planet. And I found solar was kind of a solution for that. I could keep building things, but also have a more meaningful impact on the world. So that's kind of what started my career in solar. Right now, I'm a licensed electrical contractor. I'm a licensed roofer. And I do have my NABCEP certification, which is the North American Board of Certified Energy Practitioners. That's like the most advanced solar certification you can get. I did start my own company in 2020. I've worked for a lot of companies over the years, some of the biggest names in solar, but I sort of got out of that business in 2020. I sort of reevaluated things and wanted to create a more custom contractor that really put the client first and was just focused on doing a great job for people. So I started my company in 2020, Solistar Solar, to be that design build contractor that was really focused on just doing a great job for folks in the Chicago area. We have our own in-house installation crew. And we are often hired as a third party to go inspect other solar contractors' work, or fix things out there in the Illinois area that maybe weren't installed very well. And then in my free time, I teach solar classes for Solar Energy International, just trying to help get the good word out there and help make sure that other people can install solar as good as possible. I'm a believer in sharing knowledge, not hoarding it. You know, so I'm happy to share, you know, all the lessons I've learned over the years. I started with this image right here on the first page, one, because it, you know, it's like well, it's a cool picture, but it's also right in the city of Chicago. This is Studio Gang, so the headquarters of Jeannie Gang's architecture firm. And I think this is kind of a neat installation just because it's really low profile. You can't see it from anywhere, but it's up there humming along, helping power that architecture studio. Let's see. The slide didn't progress here. Let's see. There we go. All right, so here's another one that's this is a project that Sean and I worked on together. This is a Goldberg General Contracting and was it Woodard Tanucci Architects. This is the Sybil Shearer Dance Studio at the Ragdale Center in Lake Forest. And I thought this was a really cool picture. I took this off their website. But you know, it shows like this really beautiful building that has, you know, a bunch of sustainable features, and there's a big solar array up on the roof. You can't see it at all, of course, but it is up there humming along. I was checking it today, and you can see that graph or that little power flow chart in the upper right-hand corner. That's showing the power flowing from the roof into the building. And that building is heated with a heat pump that Sean and his team put in. And you can see that the whole building is solar powered today, and there's power flowing back out to the grid. You know, so it's not like a super cold day today. It's, you know, 40 something degrees out. So, you know, maybe the building doesn't need a ton of energy. But I thought it was pretty neat to see that this building is 100% solar powered today, and it's heated with electricity. So I thought that was a pretty uh, a nice example to show you guys. And then you can see on the lower right-hand corner, you can see the solar array up there, which, you know, I think has a kind of a nice grid look to it. You know, some people don't want to see solar at all. I'm personally not one of those people. I love seeing solar, but I do love seeing good solar. You know, that's you know, I'm sure you guys have all seen it. You've seen like broken up solar panels where, you know, there's one panel here, one panel there, and there's a bunch of conduit that connects it maybe on the roof that just, you know, doesn't look aesthetically pleasing. But, you know, you can see this array down on the right. You know, it's thoughtfully designed. You know, I worked with the builder and who worked with the architect to make sure that we had a really nicely framed system. Even though you can't see it, you know, it still looks good. It's a nice clean rectangle. And that's not by accident. That's because an architect was involved in the project, helping to make sure that it was, had a good aesthetically pleasing end result. So when you're looking at, you know, designing a PV system, there's kind of like there's like three main components. You know, one is energy use. You know, how much energy does this building use? And of course, that's highly variable. You know, some houses or buildings use very little, and some use a ton of electricity. So understanding that is important. And you know, it's when you're building a new house, it can be difficult to figure that out. But there are some rules of thumb that we can follow. And then of course we need space for solar panels. So the more energy that the building uses, the more space you need. And this is very similar to what Sean was talking about, where, you really want to focus on, using as little energy as possible, trying to get down to the smallest system possible. You don't want to have a ton of solar panels on the roof of a building, if you can help it. But as homes electrify, we do need more and more panels to meet the need. And then of course we have the homeowner. Homeowners they have wants, they have desires, and oftentimes they're constrained by a budget. So, we sort of try to find a perfect system that ideally they have enough roof space to offset all of their energy use, and then enough budget to pay for that system. That's the perfect scenario. But often we're constrained by one of these things. Maybe we don't have enough roof space, or maybe they don't have enough budget to, cover the cost of all their energy use. But that's okay. You know, even if you're offsetting half of your electricity use, that still is, you know, taking a chunk out of the long-term operational costs of the building. And it's also reducing, you know, fossil fuel-based electricity that would otherwise be coming from the grid. So, you know, you know, there's ideal scenarios, and then you know, the real world. And then of course, you know, I know we're talking to architects here, and I have had the pleasure of working with some architects over the years that also have thoughts and opinions. So, you know, we don't always get to put panels on the front of a house because maybe the architect doesn't want them there. Even if the homeowner does. I've had situations like that come up where the homeowner doesn't care, but the architect does, which I think's sort of funny. But you know, we basically find a blend of these factors to come up with the best system design for the specific application. So when we're looking at, you know, so a solar system, you know, we are constrained by the size of these solar panels. There are like custom panels out there in the world, but you know, generally speaking, the really truly tested and reliable products are basically all these rectangles. They're about 3.5 feet by 6 feet. So that's 21 square feet per panel. So they're not squares, they're not circles, they're not triangles, they're rectangles. And you know, that can fit really nicely with some roofs. But you know, they don't always look beautiful on some roof types, maybe some that are, you know, shaped like triangles themselves, you know, and then we put a rectangle on there, and it might not blend in aesthetically quite as nicely. But lots of roofs are rectangles. So here's an example of a garage where you know, I think we put an array that fit quite nicely right in the middle. It's perfectly framed. But you know, it doesn't always work like that. Most panels are between 400 and 500 watts each. And a typical home in Illinois needs, you know, I've installed systems on homes that are, you know, as few as 10 panels and as many as 150. And that 150 panel system didn't actually meet all of their energy usage. We just ran out of roof space. It was a pretty big home, but so you know, usage really varies. And that home that needed 100, you know, maybe 200 panels was right on the lake. It had huge glass windows and 5 air conditioners. Sean unfortunately wasn't able to help them. I don't think maybe they wouldn't need so much energy if they had a more efficient HVAC system. Maybe I should recommend you, Sean. But yeah, then most homes, you know, the average home needs like 20 to 30 panels. Um, you know, that's pretty typical of an average home in Illinois. But again, that is changing. You know, as people start plugging in their electric vehicles, you know, just to power an EV to go, you know, 10,000 miles a year, which is average travel for a car, you know, you're talking another, you know, maybe 7, 8 solar panels. If you have 2 EVs, maybe that's another 7, 8 right there. So now instead of 25, you need 40. Add a heat pump and start doing heating in the winter. Well, you might need a few more panels there too. But you know, I'd say, you know, if we say on average, a home needs 25 panels and they're 21 square feet each, that's, you know, 525 square feet. So, you know, that's about how much roof space an average home would need to offset their usage for the year. I'm sure some of you are familiar, but the 2021 International Residential Code has a call out for solar ready homes, and they're recommending a minimum of 300 square feet. You know, that's nice and all, 300 square feet's nice. But I keep getting these designs from architects that show a space of 300 square feet for solar, and then they're wondering why, you know, I'm saying that's only going to offset 40% of their energy use. Well, it's because that's a minimum standard. So, you know, 300 square feet is great, but it's really just it's not enough for a modern home. You know, 500 to 1,000 square feet of roof space for solar would be much better. So a 25 panel system at say 450 watts would be, you know, 11,250 watts. So that's the power rating of your kind of average size system to meet your annual energy usage. And sometimes we shorthand that, instead of 11,250 watts, we say 11.25 kilowatts. And I'll come back to those numbers a little bit later. We touched on a few of these things on sizing considerations. Most homes don't have snow melts. Most homes don't have hot tubs or saunas or pools. Historically speaking, I should say. They don't have EVs historically or induction ranges. If you get into snow melt systems or in-floor heating in your bathroom, these things are great, but they do use a lot of electricity. So, just things to keep in mind. If you want to really solar power a house, you need a minimum of 500 square feet. If you start adding some of these things like snow melt systems and in-floor heat, just know that, you need more solar panels if you want to offset all of the usage. So again, in terms of spacing, it does differ if you have a pitched roof or a flat roof. Flat roofs are great, where my old boss used to call Chicago the Saudi Arabia of flat roofs, which I thought was pretty funny. I think nod to the oil industry there, but here we have a ton of flat roofs, which is which allows you to hide a lot of the solar. So if that is something you care about, having a flat roof design can really keep things low profile and keep the solar out of the way. But you do need more roof space with flat roof. So here, this photo on the right, you can see that as you tilt up a solar panel, it creates a shadow behind it. And to prevent that shadow from shading the other solar panels, you have to space them apart a little bit. So this is a project in Northbrook, and it has about an 18-inch space in between solar panels. So it takes a little bit more space to have a flat roof system. It's just less power density. So maybe just as a rule of thumb, you could say on a pitched roof, you get about 20 watts per square foot. And on a flat roof, because of the shading, you get maybe 15 watts per square foot. When you're thinking about a good roof for solar, you want one that has minimal vents, minimal skylights, and minimal dormers, ideally doesn't have a lot of shade. So I do get presented with designs sometimes. These homeowners really want solar, or maybe the architect wants solar, and they show me the design and it's just covered in dormers. And that's fine. I think some people really like that aesthetic. That's great if that's what you or the client likes, but they're just probably not going to be a good client for solar, at least on-site solar. There are things like community solar that they can get involved with to help reduce the carbon use of the home, but they're not going to be a good candidate for solar. You need a nice rectangle or square roof, ideally, to be a good site for on-site solar. So unfortunately, you can't fill the entire roof with solar panels anymore. You used to be able to, but now we have the fire codes that require setbacks from the ridge and gable ends of a roof. So you need a 36-inch pathway from the ridge or at the ridge, and you also need 36-inch pathways on each gable end. The more modern codes, so 2018 and 2021, that pathway at the ridge is reduced to 18 inches if the solar is less than 33% of the plan view roof area. And then you only need a single 36-inch pathway from eave to ridge on one side of the array. If there's a hip roof, you could have that 3-foot pathway shared between on each side of the hip. But there are pathway requirements. So, I know that's all a little bit technical maybe, but basically you can't fill the whole roof. You need space to walk around the array for firefighter activities. On a flat roof, you need 3 feet around the entire perimeter of the roof. So I think at the Ragdale, the dance studio in the lower left corner, you can see that very clearly. We have a pathway around the entire perimeter of the roof. On this other job in Lake Forest, you can see here, this is another one that Sean did the HVAC on. We have a little bit larger pathway. You can't see it in this photo. I wanted to show this photo because I think it's a beautiful house. But we pulled it back from the edge a little further, so you actually can't see this array from the ground. This is a drone shot, so you can see it pretty clearly. But from the ground, you actually can't see the solar array. So, sometimes you can't fill the roof for fire code reasons, and sometimes you don't want to fill the roof because you want to have a certain aesthetic where you might not see the solar panels. Oh, and then of course zoning too. There's, for many of you are building in historic areas. That's another reason that you might want to hide the solar panels is that zoning rules just don't allow it. In terms of design criteria, the solar panels are very light. They're less than 3 pounds per square foot. When you get into a flat roof system, the weight can increase because we're not always penetrating the roof, like mechanically fastening the array. We might be doing a ballasted system, so we're using concrete blocks to hold it down. And that might increase the weight to, 5 PSF or maybe even 7 PS of dead load. So you need to make sure the roof can handle that. But I've never had a modern roof fail structural engineering. So as long as the roof is built to code, it should be fine. The ideal tilt angle for solar is, between 10 and 40 degrees facing south. You can face the array, the array can be tilted at a 5 to a 60-degree angle without issue. You just start to lose performance. You can also face arrays east and west. And east and west can actually be advantageous if you're trying to offset high-priced energy. The energy costs in the morning and afternoon are actually more expensive. So if you're on hourly pricing, an array like this on the right here, this is an east-west rack system that has a very high power density. So, it's really tight, a lot of watts per square foot here. And we're offsetting east and west solar or east and west electricity use, so morning and afternoon electricity use because it's an east-west system. That's just a good example of how you can sort of use these different technologies to improve your energy offset. The system on the lower left is, this customer wanted all the solar they can get. They wanted to offset all their electricity use. And we needed to use the north face of the roof to do that. North is not typically ideal in the Southern Hemisphere, but it does work. So, here we have south, east, and west facing panels that are working great. And then we have this huge north facing array that without it, they would be using energy from the grid. So it's not ideal, but it does produce quite a bit of electricity and enough to offset all of their energy usage. So it made sense in that case. You just sort of need to be careful when presenting a north facing system to a client. You don't want to, you just need to be really clear that it's not going to produce quite as well. As long as the client still wants the system, then it makes sense. Some other things I've seen, I've seen someone do like a solar ready with conduit from the electrical room to the attic, and they put a 2-inch conduit in there. 2-inch conduit is a giant conduit for like an electrical service. But we really, generally speaking, need 3/4 to 1-inch conduit from the roof down. So even this, giant system here on the left, that only needed a 1-inch conduit. And the system here on the right, pretty good size system, that's a 3/4 conduit. So that's about what's needed for most systems. Some people don't have roof space, but they have space in their yard, or in this case, these folks in Lake Forest had a nice prairie outside. So we put this 108 panel system in, and it offsets all their electricity usage, and they grew a prairie around it. So just another approach. This is a few hundred feet from the house, but you can always just oversize the cables and put the array wherever you need to. There's just a couple photos. just wanted to show different approaches to solar. These are all existing retrofits. We're kind of just working with the architecture of the building, and all the vents and skylights that exist up there. Ideally, again, we have these nice rectangles, but we can sort of modify the array as needed. What's interesting about this array in the upper right is that the homeowners didn't want to see the solar, but we still fit like 130 panels up there, and you can't see this thing from the road. It just has to do with the architecture of the building. It's just how it's built. So there are ways to get giant systems on pitched roofs and still not see them, and that's a great example of that. I wanted to show this one because it's a relatively small system. You also can't see this from the front of the building. But this was, the architect gets credit for this. Like, they were super communicative through the whole process. They made sure every single vent was out of the way. Even when the HVAC person put a vent in the wrong place, they had it moved. So we end up with these nice rectangles. I think they're well-framed systems. I think they just look nice, but this took architect coordination. Like this happened the way it did because an architect was involved and made sure that vents were out of the way. These systems here, they came to me after the houses were built and wanted solar. And so the vents are kind of in the way, and we had to work around them. A little bit of coordination in advance could have got these vents in different locations and had a bit more aesthetically pleasing result. There's different attachment types for different roofs. The easiest attachment type for solar would be the one on the right, an asphalt shingle roof, and we can use a flashing there like you see. It's a really reliable system, and it's the most cost effective to install. We can work with other roof types. I'm seeing a lot of folks these days want these like composite plastic fake slate roofs, which are okay. They do add a lot of cost and complexity to the solar projects, and usually the roofer is going to charge a lot of money to flash these in. But we can use a post, and the roofer can flash around them just like they flash any other vent in a roof. So it's possible to work with them, but you really want to get a solar contractor involved early in the process to ensure that the project is successful. There's a lot of equipment that goes with solar. It's not just panels. We have an inverter or like a combiner panel. There's disconnect requirements, which is often overlooked. To make a system look nice, we want to make sure that we plan for this equipment too. So having space in the mechanical room next to the electric panel and space next to the meter outside is helpful. And the bigger the system, the more space is needed. A lot of folks these days want battery systems. So batteries are becoming more and more of a conversation. Here's two recent examples of systems we put in. A battery system, needs a big transfer switch, just like a generator would. But then we need a lot of space for batteries too. So the batteries are pretty big, maybe 2 feet by 4 feet or 3 feet by 4 feet each. And take up quite a lot of wall space. And there's a lot of conduit, as you can see. The system on the right is a 30 kilowatt hour battery. The system on the left is also, that's about a 27 kilowatt hour battery. So, these are pretty big size systems, but they just need a ton of space. And if there's one thing that I've seen a lot with architects is that, there's not typically enough space provided for mechanical equipment. And so if a homeowner wants energy storage, they need a lot of space. And that space ideally for batteries is in the garage, like an attached garage, or in a drywalled mechanical room. So you can put batteries outside, but they don't work so well when it's really cold. So best to put them in an attached garage ideally. And then, for a successful project, it takes three things. It's good design, quality components, and a qualified installer. That's a little pitch for myself. But it's not enough to have good parts. Design's like fairly easy, but as you get into batteries, it does get more complicated. A lot of people say they can install solar, but it's fairly easy, but there's a lot of ways to mess it up. So, and if you want a really good product in the end, if you're building a house, like it's so important to get the solar installer involved early. I cannot tell you how many times I've had people say, "Oh, I'm just going to get the house solar ready." They have their project electrician run the conduit from what they think is the right place to what they think is the right place, and they didn't start at the right place and they didn't end at the right place, and they don't have as aesthetically pleasing result in the end. So if you are thinking about solar in a project, even if it's just solar ready, I would recommend getting a solar contractor involved to help make sure that that project is successful when it comes time to put in the solar later. This is just kind of the process. I'm going to skip over that. And then this is a bunch of small print that I want to share. You don't need to read it. I wanted to make this slide so that this could maybe get shared with you guys. And these are just kind of basically notes from the presentation. The only thing I didn't talk about is cost, and there's a ton of rebates and incentives. So the system's pretty cheap in the end. So sorry, I think I talked a little long, but I hope that was helpful. And I'll turn it back to AIA.
Thank you. That was super helpful. I think I was hoping to get some like Cliff Note guidelines, which you gave us a lot of, so we'll save a lot of my questions anyway. Greg, do you want to like start off with some of the questions that are in the chat? If you guys, I know we're kind of getting close to one, so as long as you guys want to hang in here, I'd love to get through a few of these questions.
Yeah. Yeah, without running too long. I think there's some good ones. And yeah, thank you guys both. I mean, that was great. Jumping into the first question, can you explain, this is directed, I think, towards Sean. Can you explain in more detail how a hybrid system works?
Absolutely. And I'm going to go ahead and reshare my screen. I had some time to pull up a few slides while Garrison was speaking. So a hybrid system is kind of your first step in the good, better, best evolution of energy efficiency. And what you really can do today is a couple different ways. You can buy a complete new furnace, air conditioner, and outdoor heat pump to work together. Or there's a number of manufacturers like Mitsubishi who have developed just the coil and outdoor condenser that would replace a regular air conditioner and be mounted on an existing furnace if your furnace is in good shape and is relatively new and already efficient. A hybrid system really is a dual system. It uses an air source heat pump outside, which is something similar to an air conditioner, but instead of only rejecting heat from your house to the outside, which is what an air conditioner does, a heat pump actually reverses that process and can pull heat out of the air and bring that heat back into your house and allow you to use it to heat through a refrigeration cycle. So a hybrid system, like the one I'm showing here, would have a controller built into it where when the thermostat asks for heat, we've pre-programmed this to determine what temperature outside makes sense to use the electric, and what temperature outside it makes sense to use the gas furnace. And so it would then make the choice of running the electric heat pump when it's the most efficient and cost effective, and then switch over to gas when that's the most effective. And in this case, it's all done just through some initial setup settings. And so the homeowner does nothing but sets their thermostat to 72, and the controls then determine when the best time it is to go from electric to gas. And there's, again, some easy calculators that come with these systems for us to calculate out what that crossover temperature is. We just have to know what you're paying for gas and electric at that point in time. And then if it ever changes in the future, we can rerun that calculation and change the settings to something else.
All right, great, thank you. Next question, a little bit, somewhat related. This is from you, Celeste. What is a low ambient heat pump? Does that mean you don't need radiant heat or not really?
So No, I still love my radiant heat, Celeste. So that's still going to be there if we choose to have it. But a low ambient heat pump just means it's better designed for application in the northern part of the country where we get to colder temperatures. A standard heat pump really loses its ability to do much to help your heating load at about 30 or 40 degrees, depending on the design, manufacturer, and everything else. A low ambient heat pump is actually designed to operate down to much lower temperatures. So you can kind of see in the slide I'm leaving up that that unit all the way to the left, the SL22, that particular unit gives 100% output capacity at 5 degrees and can actually run all the way down to minus 20 degrees and provide some heat. So if you had a situation where you had an electric resistance heater as your second form of heat, we want to run that heat pump as much as possible, even if it can't do all the work by itself, because we don't want to turn on an electric resistance or some other form of less effective heat that costs us more to operate. So low ambient heat pumps are simply those that are designed to give us much better capacity at lower, colder outdoor temperatures to try and use less of other styles of heating media that might cost more or be more restrictive.
Okay. Another one, this is, I think, geared more towards Garrison. The cover photo is intriguing of your presentation with relatively flat panels. What are the pros and cons? Any tips for maintaining roof for leaves and drying out, etc.? And then I think further down in the chat, there's a couple other questions on similar topics. One being, how does a solar panel array, how do you plan for a future install without having any worries about compromising a roofing warranty? And then, examples of panels installations on historic structures, which I think later on in your presentation, I think you showed at least one or two of those, Garrison.
Yeah, sure. Yeah, all good questions. Yeah, just starting with the low slope one. So that one on Studio Gang was a 5-degree tilted array. Really, we did that to maximize roof space or increase power density. If we did a 10-degree array, it would have pushed into the fire code setbacks. So the 5-degree allowed us to get a larger system size. In that case, a disadvantage of that is that the panels will get a little dirtier. So you need to build into your performance calculations a little bit more losses. Snow might also sit on them a little bit longer. So those are kind of the downsides. On the upside, a lower tilted panel, one can't be seen. So that's helpful for historic preservation. Those houses in the historic preservation districts, you can't see the array from the ground. If you can see it from the ground, it won't get approved. So a 5-degree tilted rack or a flat flush mounted panel is a good choice there. It's true that sometimes debris can get trapped in those arrays. So a lower sloped roof or tilted array might need more maintenance. Like maybe you want to have your installer come out every 3 to 5 years just to check on it and make sure no trees are growing in the cracks or anything. But yeah, I guess it does tie into that historic preservation question. I have had projects approved in those like landmark locations and things like that. But you do need to be careful about where you're putting panels because you can't see them from the ground. In terms of roof warranty, most attachments that we use, they work with existing roofs and they don't void the warranties. For flat roof systems, so if you have like a Firestone TPO or something like that, like a nice membrane type roof, we do need to submit a warranty alteration form and get it approved. And then we need to work with a roofer of record to do any flashing that's going to happen on that project to ensure that the warranty is maintained. So that is important that you work with a roofer of record and yeah, get approval there.
Okay. Status of solar shingles.
Yeah, solar shingles they're coming along. They're still incredibly expensive. So they're most customers want to install solar to save money. or reduce their carbon footprint, or both. I have very few customers that only want to do it to reduce their carbon footprint and will do that regardless of the cost. If you do have a client like that, then they would be a good candidate for solar shingles, because there's not really a return on investment. The cost is just, extraordinarily high with the solar shingles. And then the challenge with them is long term. I've been doing solar a long time, and I think that, you can install great systems that require minimal maintenance, but solar's not maintenance free. And, finding someone who is both a roofer and an electrician is very rare. So it's like if you have a problem in 15 years, where are you going to find this magical roofer electrician? It's just they're like unicorns. I just like hesitate to recommend something to somebody that maybe can't be serviced by a handful of installers. We do have a roofing license and electrical license in house, but I still hesitate to recommend it because I worry that yeah, just I'd rather recommend a trusted, proven technology that I know can be fixed by basically any competent, qualified installer. So I'm kind of sticking with classical panels for now. I love early adopters, and if people really want it, I would help them with it. But yeah, it's not my go-to recommendation, just in terms of long-term reliability and cost effectiveness.
Okay. I think this is a question I posed during the presentation that later was addressed to a certain degree. Emergency backup power. When you are trying to go gas-free. I know we checked into the feasibility of this a few years ago on a project, and it was a question that you could get backup for hours, but not 2 or 3 days, which is something a lot of our clients, are hoping to get. Is that different these
Right.
days, or I know the more batteries, the more capacity.
Yeah, right, exactly. So the key for a energy storage system is having space and then having the budget. If you have the space and you have the budget, then we can definitely back up, a modern 400 amp service for days. Even, we're seeing 800 amp services these days in residential homes. And you can back those up, but you're going to need the batteries to be outside of the main structure, because you have a limit on how many batteries you can put in a house. So maybe you need to put them in an additional dwelling unit or in a garage. But you can do it. Most systems are limited to 200 amps for like most cost-effective systems. So they're kind of designed around a 200 amp service. If your service is bigger than 200 amps, then we're gonna start looking at stacking these 200 amp units, which introduces some additional complexity. But it's certainly possible if you have the space and if you have the budget. People oftentimes say like, I want to back up my whole house, and then I'm like, okay, great. How much space do you have? Oh, we don't. Can you put them upside down on the ceiling? I'm like, sorry, no. We did 20 feet of wall space. So that's kind of what we're looking at.
Also, when you're considering battery storage spaces, you also have to consider there's mechanical codes requiring for ventilation. There's special sensors that have to be installed that can sense for a battery leak. So there's more than just the space for the batteries too. There's also mechanical ventilation requirements that are coming out as the codes change.
Yeah, it's a good call, Sean.
I know that because of this presentation, I'm definitely seeing that, you guys gave me good ideas in terms of how you really do need to plan very well in advance. And I would just say in terms of like maybe how a house gets, if you're doing a pitched roof and you don't want to see it, how you might think about like the pitches and how you design that house, you know what I mean, to leave a place for it like that. It really, I know it's sort of obvious, but that just was helpful for me to see all those examples you gave. And Sean, I liked all these other like HVAC ideas that I didn't even know existed. And I feel like I'm learning that, early on, like planning sort of like the amount of windows versus the reality of what you need to do and the cost you know what I mean, just is all super intertwined and having that conversation early on. So I liked all your beginning conversations. I might tap you up for introducing you way in advance, rather than I think a lot of times we are designing and then coming in and then having the conversation when it's hard to pivot. So you guys brought a lot of information today.
Thanks, I'm glad.
Yeah, real quick, I see Tim Hawkins had a question about solar facades. Just
Yeah,
really
yeah.
quickly,
Would love
yeah,
that.
it is possible.
Yeah.
It is possible. There's new technology coming out that, is geared towards that market. But right now you can put traditional solar panels at a 90-degree angle. You just have to be really careful with what racking system you select. They need to be, mechanically bolted just to make sure that they stay in place. Because you have gravity working against you, but yeah, it is possible.
Did I dream this, or did it exist, where I feel like it would be such a good idea if Windows would be your solar panel,
Yeah,
because then we could do everything we want with all our bazillion windows, and yet it would also be providing.
That's out there already, isn't it? Like,
yeah, it's out there.
in
It's just
preliminary form?
yeah, the power density is just pretty low and the cost is pretty high. So it's kind of up there with solar shingles. I mean, solar shingles are closer to prime time, but the solar windows are, yeah, they're definitely a novel approach that costs a lot of money and has limited output.
I had a question that I thought of also, I forgot to ask, which is, do you guys, this is kind of like my overwhelmed person asking, do you guys know of any consultant that helps you guide the client so that you're not the one, because we get paid to be an architect. So like, we don't always have the fee to dig through the rebates, and, the client's not even really interested anyway, and you're kind of presenting them this. Is there somebody that like can sift through like the daily sort of like rebates and things that are out there to help do like a more comprehensive, like what it's going to cost and what you might save? Anybody know if that exists? Anybody in the chat either?
I mean, I know that we do that for every one of our projects,
Oh, you
and that's
do?
a free service. Yeah, it's just, what's involved, if it turns into a project, great. If not, hopefully we just help to educate people. So.
Well, okay. Thank you, sir.
Same here. We're here to help consult on the front side of designs. We have a consulting group that gets involved early on and design projects. But there's also a number of consortiums that are coming out. That Desire org website I mentioned is just one. There's Pika and a couple other ones that are coming along now. Pika's PIKA, that are actually trying to create like the bullet point version of those websites where you can kind of just go in and say what you're trying to figure out, and it'll bring it all the way down to the answer versus just being a share location. So I think you'll see more of that from some startup companies that are coming out that you'll hear more about in coming months and years. So
That's fantastic.
Right. Well, this has been great. We've taken up more of your time than budgeted, guys, but I think, there was a lot of very interesting stuff covered in this conversation. So I think it's overdue for us to wrap things up, but, thanks again. Celeste, I don't know if you have any additional comments.
Just that I saw that the AAA says they're going to put this presentation on their YouTube channel. So, I'm not exactly sure where to find that, but I'm sure it's a Google search on YouTube, just AIA to find that.
All right.
Oh,
Subscribe.
she also says she'll send it out. Great, because I was screenshotting all over the place because you guys were awesome.
All right.
Thank
Okay,
you, guys.
Thanks,
Thanks
guys.
everyone who
Thank you.
joined.
Yeah.
thank you, everyone.
All right. Take care.
Bye.
Take care.